So if the sum of x consecutive integers is 0, that tells us some things. In order for the sum of any series of integers to be 0, if they're consecutive, it basically means that they need to be the numbers on either side of 0. Oh, I should probably write it the right way. So it would be 1 and -1, and then here there'd be 2 and -2. So for any number to the left of 0 on the number line, there needs to be 1 on the right. It also means that automatically there's going to be an odd number of numbers because you have the pairs of numbers balancing each other out, and because they're consecutive, 0 is always going to be in the middle. So we don't know how many consecutive integers there are in here, but we're looking for which of the Roman numeral statements must be false. So statement 1, the product of the x integers is 0. So we established that no matter what, in order for the sum of all the integers to be 0, they have to be balanced around the 0 point, and 0 has to be in the set. You multiply any number of integers times each other. If 0 is one of them, the product will be 0. So statement 1, definitely true. So we can cross off the answer choices that say statement 1 is false. Statement 2 says that x is an odd number. Now remember, we need a pair of numbers, like 1 and -1, to cancel each other out for the sum to be 0. So that's going to be an even number of numbers, but 0, because these are consecutive, will always be in the middle between these sides that balance each other out. So there will always be an odd number of numbers in the set of consecutive numbers, consecutive integers with a sum of 0. So statement 2 is also true because it's always going to be an odd number of numbers. And since we just established that it's always an odd number of numbers, there is no way that statement 3 can be true. If it's always odd, there's no way it can be even. Also, we established that statement 2 was true, so we already got to choice C by process of elimination. But since it's always odd, it's definitely never even. Therefore, answer choice, or Roman numeral 3, answer choice C is false.